read and see how your diagram fares to my diagram. So Amanda is enjoying a hot air balloon ride, so we know we're somewhere up looking down, right? I'm assuming. And there's an altitude, right? Altitude of 2,500 feet. That's the height, by the way. She spots the forks at an angle of depression of 34 degrees. So forks is found at an angle of depression of 34 degrees. That's important. At the same time, right, from the same position up top, right, she spots Winnipeg's tallest building, the Artist Reed building, at an angle of depression of 27 degrees. So that would be the other building. So let's picture this, right? You're up on the hot air balloon ride, and you're looking down. You're looking down, right, to the forks, and you're just tilting your head a little bit. It's almost like you're just tilting your head and you're looking at something else, right? So that's the idea here. Assume that Amanda's looking in the same direction. So I added that to be specific. It's not like you're looking this way to your left and then you're looking to your right at something else. We're looking at this in the same direction, okay? The angle is changing. So I will try my best to be very specific on a quiz or on a test. You're not guessing. But some of these questions, I'll have to tell you, sometimes you might have to make an assumption or two. And so if that happens to you, if you solve it, you're like, oh, I drew it completely differently, sometimes it will happen to you, okay? It doesn't mean that you don't know how to read or whatever. Maybe sometimes it's just not clear enough. So here we go. The most important thing of this whole operation is sketching it, so interpreting it. So I'm going to grab my ruler here. And everybody thinks differently. Some of you always go from left to right. Some of you go right to left. It doesn't matter. All right. 39. So I'm going to start here. I'm going to assume that this is my hot air balloon ride. So I'm going to call that H. I'm just going to give it a letter. And we're looking down at an angle of depression of 34. So before I start my angle of depression, I'm going to introduce the imaginary horizontal line. Because remember, an angle of depression needs to be measured from a horizontal. And this is my ground here, which is parallel to that imaginary line. This is the ground, okay? So you got to imagine you're up here, and then you're looking down at an angle of depression of 34 degrees, okay? So this is 34 degrees right here. You're starting from the horizontal, and you're measuring down 34 degrees. Page 39. Okay, so that's number one. So what do we call this? Give it a letter. That would be the forks. Okay, the forks, if you want to call it forks, that's fine. Okay, but that's 34. And would it make sense to you that I placed the Artist Reed building further to the back of it? Because if this is 34 degrees, 27, right? 27, it's kind of like you're actually looking further out. Okay, so I'm going to draw another line. And again, you might have to redraw and move stuff around. But I'm going to have the 27-degree angle out here. Okay, I like the arrow pointing towards it. You're saying you started here, you're measuring to that line of sight, and I'm going to have to move my 34 a little bit. Okay, so I'll just make sure that is 34. I do kind of want to write over the line, okay, so that it's clear that it's 34 from the top to this line of sight here to the forks. This is the Artist Reed. The Artist Reed is that tall building that they kept on working on for so long, right? I think the Keg is the restaurant is at the bottom. It's like on Portage and Main, sort of off a little bit. That's the tallest building right now that we have. So what else do we need in here? Something is missing right now. The height. Introduce the height. And so basically you want to go back to your the hot air balloon and measure straight down. Some students go solid line. It doesn't really matter. Technically there is no solid line, right? There is no building there or anything like that. So maybe a dashed line is more appropriate in this case. So it's 2,500 feet. You need at least one side, folks. If you don't have one side, you're not in business. You're not going to be able to solve a triangle. Okay? And this is a 90 here, by the way. So that is the initial sketch. Okay? So some students interpret and then they make a clean version outside here. Like they actually redraw some of these triangles out here, which is totally fine. But this would give you a 2 out of 2 right now. You have everything that the question is mentioning is in your diagram. You have some letters or you know, little a word or two that describes what is this on my diagram. So this is what you're supposed to have. My guess is I saw some of you putting the angle of depression here. I want you to make sure you make note of that it's not here. Okay, it's from the horizontal looking down. All right, so let's fill in the rest. I like to fill this up right now with numbers all over the place. Okay, so for example, this 27, this is a transversal, right? Think about it. These lines are parallel. I'm going to just do this here. Okay, these lines are parallel to each other. So if there's a 27 there, you can bring that 27 in here. If this is 34 from the horizontal to this transversal, okay, where's that 34 going to go? Oh, over here, Mr. Dirksen, right? No. Remember, it's alternate, so it actually comes inside here. Be careful, okay? I used alternate interior angles to bring that down. Let's fill in some more. Maybe I'll use a blue pen for the second more angles. Do you see this straight angle right here? You see that straight line? So that can allow you to solve for this angle here. So let's do that right away. This angle is 146. And I will show the work here. I just went 180 minus 34. Okay. And that gave me the 146. So if you're wondering what happened there, I just used supplementary angle properties. And so now that you have these two, you can solve for that angle here. And notice that I'm coming away from all that busyness there. I don't want to like add numbers here. So I just it doesn't matter where you make that semicircle, that arc. But this angle can be found in two ways. You can either go 34 minus 27 to get this, or you can use sum of triangle, right? You've got this triangle here, of which you have, two angles, right? So you can find that angle using either one of those methods. Okay, so I'm going to do some work here. 180 minus 146 minus 27. That is going to give me 7 degrees. Okay, 7. It's a small angle. It's not drawn to scale, so it's not very realistic. I get it, but there's the 7 right there. So what have I done? I've just filled this up with a bunch of angles. It's almost like going back to chapter 2. When you have one angle or two, right, and you've got transversals, boom, the whole thing can technically fill up with angles. So that's the nice thing. It's a review of the previous unit. Okay, what is it asking for? Calculate B. Now we're going to tackle B here. Calculate the direct distance between Amanda and the forks. Maybe for you, should we call this A rather instead of H? Because then we have Amanda and forks, AF. I'm going to go ahead and do that. If you don't mind, change this to A. That's Amanda up there. Right, so now let's solve for that. I'm going to re-sketch things. I'm not going to add to this. Okay, I'm going to sketch this out. So between Amanda and the fork, so we want this distance right here. So I'm going to use, which triangle do you think I should be using? There's a right triangle here. There's an oblique triangle there. Like this one here, this one. That's an oblique triangle. The problem with this triangle right now is you know all angles, but you don't know any side. So I wouldn't be using it right now. Instead, I'm going to focus in on that triangle right there. Do you have a pair? 34 is across 2500. And the 90 will allow me to solve for that side that we're interested in. So for B, if you don't mind, I'm going to just do that on the side here. I'm going to sketch that out real quick. So I'm just going to make a right triangle with all the pertinent information. That's a 90. This is A. This is F. That's the one I'm interested in. I'm going to put an X there. I know that this is 34 degrees here. I'm going to copy that over. And I know that this is 2500. I'm going to copy that over as well. You've got your pair. Okay. So we know this is sine law. So we're going to go sine of 34 over 2500 is equal to sine of 90. Anybody remember what, did I talk about sine of 90 before? Yeah? Did I tell you it's 1, right? Okay. I'm teaching trigonometry in the afternoon too, so sometimes I'm forgetting what did I say to this class and to my afternoon class. So you got to hold me accountable. So cross multiply and divide, right? So that's 2500 times sine of 90, which we know is 1, divided by sine of 34. SOHCAHTOA would work here, okay, because it's a right triangle. Absolutely fine. I would just caution, don't use it if it's not a right triangle. Okay, so I'm just going to stick with sine law at the moment. So X is going to give us, let me see here, if I get this right, 4,470.73 feet. Okay. So that tells us how far Amanda is from the forks, like the direct distance. So if you are into highlighting, okay. You do that. There we go. And maybe I'll just section this off. Right, we've done some work there for B. Let's do C right here. What is C asking for? Determine the direct distance between the two spots. So when it's asking the distance between the two spots, I'm hoping that you understand that it's like between the two locations we're looking at on the ground. So we're looking for this side right here. Okay, so let's transfer that triangle over here real quick. Just make a sketch. Okay. So let's transfer over what we know. We know now that the 4,000, right, 4470, 73 is known to us now. I'm going to highlight that here. And I'm also going to highlight it in my original. Okay. I'm going to highlight it in the OG. See, trying to be cool here. 146. 27, and this is 7 up here. I figured all of that out already. And let's call that the side that we are wanting to solve for. Let's call that Y. So this is F, right? And this is the artist. I'm going to call this AR. Because otherwise we've got two A's. That's not cool. So that's what we're solving for. Again, we have our pair, and we've got this angle, but that would allow us to solve this distance. We don't want that one. We need to use angle 7-degree angle here to solve for that side. So we're going to go sine of 27 over 4470, 73. And you're going to go sine of 7 degrees over y. And so y is going to be cross multiply and divide. So 447073 times sine of 7 divided by sine of 27. If you do that correctly, you get 1,212 feet. That's the orange side, right? So I'm going to give this an orange color. We solve for that one on the redrawn triangle, and on the very original one there, we solve for it right here. Could I find a direct distance between Amanda and Artist Reed building? I could have asked you for that, but we're not going to solve the whole thing right now. So just make sure when you solve these, okay, make sure you clearly tell me which one is the answer for this section. Like either a statement, or I'm clearly labeling it on my diagram, and I'm letting the audience know that's what I solved for. Okay, don't just have numbers appear all over the place, and I don't know what's what, right? I need to understand you know what you're doing, okay? That's important. All right, let's do the one on page 40. Again, I'm going to give you some time to sketch that, okay? And if you're done page 40, try 41 and 42 as well, okay? So don't just sit there idle. The purpose of today's lesson is to make sure you're ready for word problems in the future, okay? This type of word problems. There's multiple triangles. Start with the one that has the most information. So it hurts. Okay, I'm going to go over this with my answer key. Oh, I don't have this one, so oops. Let's draw this real quick. I want to highlight a few things that I saw that I need to make sure you understand, okay? So, for example, in this case, we've got Agnes and Fred. They are, make your diagrams large enough to add information, but not too large that you use up a whole page, right? So you kind of want to make sure you find that happy medium. You know that Fred is here, Agnes is there. Mr. Erickson, does it matter? No, it doesn't, right? If you put Agnes here, Fred there, it doesn't matter. In this case, it's specific to, saying that Fred has a 60-degree angle of elevation, and that the plane is somewhere up here. Should I have it off-centered, or should I have it perfectly in the center? Off-centered, because the angles are different. Who's looking up more out of the two? Fred, because it's got a 60. So I'm going to make it a bit realistic and make the plane be closer to Fred. Okay? And then that's how I'm going to draw my triangle. Sure, you can introduce the height if you want. I'm going to leave it for now. That's Brandon up there. So I know I have a 60 degree from the horizontal to the line of sight. There's a 40 here from the horizontal to the line of sight. I know that they are 520 meters apart. Okay, it's the entire bottom of this triangle. A is asking for this right here, the distance between Agnes and the plane. So I'm going to call that side X, right? I'm going to tell my audience X represents that side, okay? You have one side length, but you don't have an angle. Most of you, I saw putting the 80 here. And most of you added a height in there, which is fine, but I would say for now, let's just not do it, right? Because I don't know the height. It's not asking for it straight away. So just do it like this. That's your sine of 80 over 520. And that's going to be what I want x, right? So I need to use sine of 60 over x. Folks, this is what I want to highlight. Big triangle, you used 80, which is part of the big triangle. 520 is the entire triangle base. So don't be mixing up. Some of you did this, right? And you're mixing up, you're going sine of 40 over that, and sine of 80 over the whole thing. Now you're jumping between a right triangle and an oblique triangle, and you're going to get it wrong. Okay, so you got to stick to one triangle at a time. X is 520 times sine of 60 divided by sine of 80. 457, right? I think that's what I kept on seeing all around. 457.28 meters is the distance between Brendan and Agnes. Okay, now it says the height of the plane above ground. You've got two options here. Okay, some of you don't like the formula. You're like, no, I'm not going to do it. That's fine. I'm going to use this. I'm going to cut that like this. I'm going to use that triangle here because I have the 457.28. This is 40. There's a 90 here. Every time you're finding the height, it is a 90. It makes a 90 with the ground. So you have your pair here, and the 40 is going to allow you to solve for h. So you can go sine of 90 over 457.28, and then it's sine of 40 over h. Cross multiply and divide like this. I'm going to show the work because otherwise you're going to say, well, you never do. Right? Divided by sine of 90, which is 1. And that is, let's see here, 293.93. Okay, so that's the height of this, of the plane above ground. Do you get the same if you use the shortcut? I'm pretty sure you go 457, that's slant, times sine of the angle that's touching it. You get the height. Okay, let's do the next one, the helicopter one. If you're copying this, go for it. This is the one that is maybe a little trickier. Let's go to 41 here. Yes, spend enough time on your diagrams. Take your time, interpret it properly, and then you do solving. Some of you just want to jump to the solving part because I know it's the funner part, but make sure you don't rush too much. A police helicopter is flying 400 meters above a highway. So that's the height of the triangle. So we're going to have a height introduced into our diagram. Spots a collision at an angle of depression of 62 degrees. Okay, so there's the collision at an angle of depression of 62 degrees. At the same time, the helicopter spots an ambulance at an angle of depression of 27 degrees. Assume, this is my assumption here, that the helicopter is in between the collision and the ambulance. How far is the ambulance from the collision? So here's our diagram. Please have a ruler for this unit. It's prettier that way. So we're assuming the ground is nice and flat. That's our assumption. Okay, and we've got the collision and the ambulance. Where should I put what, Mr. Dirksen? It doesn't specify that one is to the left, one is to the right. It doesn't. So ambulance, collision. That is how it's going to be for me. And you've got the helicopter somewhere up here. It says somewhere in between. Okay. So where should it be realistically? Collision, should it be closer to the collision or the ambulance? The collision has a very steep angle of depression. right? It has 62 and this is 27. So I'm going to put the, don't stress too much about this, just to make it a bit more realistic. But the helicopter is here, looking down at the collision, looking down at the ambulance. And because of its angle of depression, you must introduce a horizontal up there. It's an imaginary line that we introduce so we can measure the angle. So this is 62 degrees, and this is 27 degrees. There you have it. And what do I need to introduce? I need to introduce the height, and that is 400 meters. Right? That's the height that I'm introducing. So that's my diagram. Let's fill it in with numbers. Let's flood it. This is 27, this is 27, alternate interior. If that's 62, this is 62, okay? Another thing you can do is sum of triangle if you want, or some of you like to just figure out this little bit and this little bit and then add them up. That's fine. This would be what? 63. And this part right here is 28. Combined, you get 91. Okay? If you combine them, you get 91 altogether. Okay, so it's good to have a lot of information there. And let's start solving now. Okay? Thank goodness it's Friday tomorrow. I know. That's the look in your face that I'm seeing that. Okay. However, let's say tomorrow you're writing an AC and you get this, something like this. How would you get started? You gotta have a side length, right? Is the side length one of the long sides of the big triangle? No, right? Okay. No, note the side provided is part of a right triangle. So start there. You start with the triangle that has the most information. And that being you need a side length, okay? Otherwise you're like, well, I've got all three angles of the big one, so I'm going to use the big one. You can't solve AAA. You cannot solve it, okay? So how far is the ambulance from the collision? So when it's like this, split it up. I'm going to go triangle 1. Let's solve that one first. I'm going to make this a dashed line. And there's my right triangle. And maybe some of you are going to discover, oh, I can do it this way, or I can do a shortcut, no problem. This is 400. This is 27. And this is 63. Sum of triangle every time. So watch what I'm going to do here. My approach is going to be this here. I'm going to solve for x. This part right here. Let's go back to the original. X is this chunk right here. It gets me to this point. And then I'm going to split the bottom. The second part there, I'm going to call that y. So I'm going to find x, I'm going to find y, I'm going to add them up. That's my game plan here. Make sure you're copying this, right? Sine of 27 over 400. This is not the only way to solve that, okay? I know that. Sine of 63 over x. 400 times sine of 63 divided by sine of 27. And let's move this up a bit. 4x, I get 785.0442. What's up with that? Why am I using 4 decimals? Because this is not my final answer, right? So at least use double the amount as you're working towards your final answer in this case. Because especially if you're going to add it up, I would like you to use 4 decimals. Okay. the next one here, let's see if I can do this without a ruler. Look at that. Beautiful. I'm going to put the 400 here again. I know that this is 62, and I'm going to call this y. So we have our pair, sine of 62 over 400. And I need this one up top here, which I already have. This is 28. I already did that earlier. Okay, sum of 180, remember. So this is sine of 28 over y. Y is equal to 212.6838. And here's my final AC, right? Distance between A and C is found by going x plus y, which is 785.0442 plus 212.6838. And that is 997.73 meters. Let me move this up for you. Copy that. I will give you a different method yet for this. There is another way of doing this. I'd like you to have both in your notes. Okay, so I'm going to go like this. Call this method 2. Method number 2. You start with one of the right triangles. So let's say I'm going to start with the one to the right. This is 400. This is 28. This is 62. And this is my pair. So I'm going to go sine of 62 over 400. And watch this, I'm going to go sine of 90. If I solve for 90, I can solve for this side up here. I'm going to call that Z. Okay? If I use 90, I can solve for side Z, which is a slant. You cross multiply and divide. And that gives you 453.03 meters. If you're highlighting, I'm going to show you that what you just solved for there is this side. But if you go to the original, we are solving for this side right here. And so once you have a slant, this is part of the big triangle as well as the right triangle, right? So you're basically solving for a side that they both share. And instead of solving both chunks separately down here, I'm just going to use the 91 here. Make sure you look up, right? I'm going to use the 91. I'm going to pair the 27 with that orange line, and I'm going to go sine of 91, which allows me to solve for the entire base. So that's another method that you could use to solve for it. So sketch this real quick. This is 453.03. This is 27. This is 91. And this is I'm going to call this AC, right? And that's the one I'm trying to solve for. I'm going to zoom into that part. So it's basically sine of 27 over 453.03 sine of 91 over AC. AC is cross multiplying and dividing. I'll just tell you that you get the same answer. So regardless of which method you use, just be careful, do not mix up triangles when you're working with them. All right. I'm going to ask you I have a few questions here I would like you to try. Pages 51 to 55. That's kind of like the soup that I'm going to use for tomorrow. So homework, pages 51 to 55. You know what? I'm going to start at 50. I wonder, did I say 50 to begin with anyways? 50 to 55. I will say this. At the very least, you should do the whole thing 2 questions for sure. But on top of that, I would say sketch every single one. Okay, sketch it. I will post the key so you can check. What happened to the how long it will take for the ambulance to get there? We'll do that a different day. Did you do the math? What is it? 20 minutes? It's actually only 2 minutes. We've got some time. I'll do it. Say what? So if you're traveling 30 kilometers an hour, how long in minutes will it take? So what I will do is I'll turn my distance into kilometers. Okay, now we know. Okay. So I know that 1 kilometer has 1,000 meters. Cancel, and you end up with 0.99773 kilometers. And this is how I solved it. If it's 30 kilometers in 1 hour, oh, let's do minutes right away. So instead of 1 hour, what would I put down there? 60 minutes. Then, right, how long will it take in minutes to travel not even a kilometer, right? So if you cross multiply and divide, you get 1.995 something, which is approximately 2 minutes.